Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is another in my series of RHCSA practice sessions as I prepare for the RHCSA exam. And the topic on this video is going to be configure disk compression within create and configure file systems. Before I dive in, I want to remind you to click like on the video if you enjoy the content, as well as subscribe and ring the bell when you do, so you can, or subscribe to the channel rather, ring the bell when you do so you can be aware of when new content comes available. So this particular topic is kind of near and dear to me because it took me a little while to figure out what's actually going on as far as this objective. And in this objective, configure disk compression. Well, what this actually is talking about is managing VDO, which is virtual data optimization. And I didn't realize that until I was trolling through some of the Red Hat documentation. I was literally searching Red Hat configure disk compression, and then the bit of documentation about VDO came up. And then doing a little bit of other research, I realized others that were studying for the RHCSA were also said, configure disk compression is about VDO. So I'm going to go over some of the basics of VDO and do the configure disk compression as a part of this little practice session. So let me open up my terminal. I'm going to go ahead and sudo into root, because pretty much all this requires root privileges to be able to do. All right, and lsdev, and I have some extra block devices to be able to work with. So VDO itself, virtual data optimization, is basically a layer of abstraction, and it provides compression and deduplication. I'm not going to go into details on necessarily what those are, what the technologies are behind it. That could be probably a whole video series on itself. But it's kind of more advanced storage stuff that we need to know about for the RHCSA exam. And so what we're going to be doing is taking I'm going to use just a block device. I'm not going to partition these off or anything. We're going to create a VDO volume. I'm going to go over some of the basic options for that, and then actually work on the objective itself of turning on and off compression. I'm also going to show you a gotcha that I learned about with doing persistent mounts for a VDO volume, because as you know, in the RHCSA exam, pretty much any configuration that you're going to have to do, or so I'm told, I haven't taken my exam yet, is anything you do, you need to be able to make it persist. And there's a gotcha with that I'll show you. So getting into it, we're going to use, let me do ls block. I think VDD is I'll do VDC is 10 gigs. All right, so to make our volume, VDO, not VOD. Oh, before I do that, I do need to say, you need to make sure that the service for VDO, systemctl status VDO, technically VDO.service, is both running and enabled with this. Now, this is the server with GUI install for CentOS, and VDO and kmod-kVDO packages are already installed. Kmod-kVDO are the kernel modules needed for this. For the minimal install of CentOS, I don't believe those packages are already there, so you'll need to remember to install VDO and kmod-k-VDO as well. But we have our service going. So now we're going to VDO create, and name equals, we're going to call it test VDO. Device that we're using, we're going to use the block device, dev VDC. And the other required option is VDO logical size. Now, there's some guidance that you can find in Red Hat documentation about this. Things like VMs and such, you can do up to 10:1. So we could present this 10 gigabyte volume as 100 gigabytes if we needed. And then there's other workloads, I think like databases and such, that Red Hat recommends 3:1. Don't quote me on those. I'm pretty sure that's what I remember reading from the documentation. So for this, Actually, let's go and do the 10 to 1. So we're going to do 100 gigabytes. Do equal. I think you can do it without the equals, but so 100 gigabytes. Now, there are a couple of other things to consider. With storage, you don't get something for nothing, So we have a 10 gigabyte volume or block device that we're going to present to everyone as 100 gigs. So how do we make that happen? VDO uses other resources, and I believe it's called UDS. I think that's Universal Deduplication Service, maybe. Feel free to put in the comments what UDS actually stands for. I'm pretty sure it's Universal Deduplication Service. But that uses RAM to help dedupe this data to be able to present that 100 gigs. And one of the things that is involved with that is choosing a type of index, either sparse or dense index. By default, the index is a dense index, and what that means is I believe it's every 1 terabyte of data, you're going to need to have a gig of RAM available for VDO and UDS to do its thing. Now this VM has 2 gigs of RAM, and so this isn't going to be a problem. If you do the sparse, the sparse, just lost my train of thought. Can't believe that. You will have you're able to get the 10 terabytes to 1 gig of RAM. So we're just going to keep the defaults here. Press enter, and it'll make our little video. And notice that it says this video instance 0 volume is ready at dev mapper test VDO. That is important. That'll be especially important when we do the testing of persisting a mount with etcfs tab. So to be able to see if compression is enabled, which I can go and tell you that it is, we can do video status, and that will dump a lot of information. Actually, I'm curious. I'm going to do man video. What I'm curious about, well, I guess there isn't one. So if there's a way that, I guess I can grep for compression. So video status grep -I compress. There we go. And compression is enabled. Now I know that I only have one VDO volume, but by default compression is enabled. And let's do dedupe as well. And deduplication is enabled. So the actual objective is to configure disk compression, and so that would be, from what I gather, either enabling or disabling, and maybe setting the index. That's what I was thinking, sparse. The sparse index to either be dense or the indexing to either be dense or sparse. So since this is enabled, to disable the compression, we would do VDO disable compression. I'm using tab completion here, which I know is available with the GUI. I'm not sure if VDO will allow tab completion with minimal install, but you can install the bash dash completion package to be able to get that. And then name equals test VDO, and compression is now stopped. And I do know that this configuration here will persist with reboots. You can do the same thing with deduplication as well. You can turn that on as well as turn it off. So this is a little beyond the actual objective. I want to go over making the file system for it and making that be persistent. So let me clear my screen, and we'll turn back on video compression. Enable compression. Name test VDO. All right, so what we're going to do is clear our screen, and ls block test VDO. That's under dev mapper. And if I were to do ls dev mapper, we're going to see our test VDO. If you want to see what that is linked to, you'll see it's linked to DM2, which is the dev mapper device. So what we're going to do, I'm actually going to use ext4 for this. So let's make us a mount point. Dear MNT ext4. And I want to mount the, or not mount, I want to make our file system. So we'll do makefs ext4. Now, one thing that's special about VDO, and I can't tell you exactly why this is. One day I'll be wise enough in storage to do that, or if you know and want to put in the comments, feel free to do that. But according to Red Hat documentation, when you create a file system on a VDO volume, you need to have it not discard, I think is like, don't discard blocks or discard 0 blocks. And the way that you do that with ext4 is by doing the -e flag and no discard. Then we can do dev mapper test VDO, and that'll make our file system. Then we see block ID that we have a file system there, and it's type ext4. So here's the thing. Now this has been, now let me mount it. So mount dev mapper test VDO. We're going to mount that to MNT ext4. And there it is. Notice that's showing 98 gigs worth of space. One thing to remember with VDO is that things like DF can give you a bit of information about it, but since this is a thinly provisioned kind of deal, we have to keep in mind the physical device and does it have enough space. And the way we can check that, VDO stats -- human - readable. And this shows us of our 10 gig device, we're using 4 gigs. And there's some other overhead as well with VDO other than what I was talking about with the sparse and dense index. And so we technically have 6 gigs available. Now, what I'm going to do, just as a little experiment here, let's go into our mount point. And we're going to create a file. So we'll use random data. So dd in file dev urandom out file, and just call it random.data, and byte size we're going to do 4 megabytes and count, let's see, so 4 megabytes, thousands of gigabyte. Let's do 5,000. Actually, let's do 10,000. I think this will work. So this is making our device. This should take just a moment or so. Shouldn't take too terribly long. All right, so that didn't take too terribly long, but I did edit some of the downtime out there. So if we do ls-l, ls-l. Let's do LH for human readable. We have 62 gigs of random.data. And if I were to do DF, we see that I've used about 6.3 gigs. And now let's take a look at VDO stats. Let me clear my screen here. You can probably hear the motorcycle outside. So at this point, we have no available space left with our VDO. I guess it makes sense because this is random data versus the stuff that can be deduplicated. So just as an experiment, it's going to make the video a little longer, but perhaps if you're doing your own study, you kind of want to see how this stuff works in action. I'll see the space saving, only about 15% of that. So let us remove random.data. Yep, we want to remove that. Read-only system file. All right, it's read-only file system. I guess it makes sense because this is now in an error state. So let's see if we can do it. See if we can force it. I might be in a position where I can't resolve the issue. So live troubleshooting. Yep. All right. So let's see. How can I handle this? I could probably give this some more data, some more space, and that might help the issue. One thing I want to try first, though, is I want to try to remount this as read-write. So let's try that first. Mount, SO, remount, read-write, dev, mapper, test VDO to mount ext4. All right, so it can't do that. Now, when I'm curious, let's try this. So we're going to try to add some data or add some storage to our VDO. So if I remember right, what we're going to do is grow physical with this. So we want to VDO grow physical, and the name is test VDO, and we're going to add to it device equals dev VDD. Well, I didn't recognize that. Okay. Guess this is some good practice for me. Oh. Let's try this. Still didn't recognize volume, and I got the path name wrong. Because I need to be able to tell it a device. So name volume. That's curious. All right, let's take a look at man real quick. VDO. And we're going to look for grow physical. As we're on the test, this is exactly what I'm going to have to do. Grow the physical volume must exist and be running with root privileges. We have name. I'll bet I might be thinking of Stratus as far as adding volumes to a pool. So yeah, I might have kind of screwed myself on this. So let's if you have mentions in the comments, feel free to put how you would troubleshoot this. But if I've run out of space, I guess so I don't have any more block storage to be able to give to that. I don't think I can just increase the size of my block. Well, there you go. Don't run out of space with your VDO. I'm not going to spend any more time on this troubleshooting, but what I am going to do is we'll make another VDO volume. So let's VDO create name test VDO2 device dev VDD, and because I still want to demonstrate the persistent mount of this. So VDO logical size equals, and that's a 15 gig thing, so we'll just say 30. All right, so test VDO2 is there, dev mapper. Now here's the thing. Let's actually give this XFS. So make FS XFS dash O, I believe, is the, let's just make 100% sure. Pretty sure dash O is the no discard for this. So I thought. Let's take a look. B. You know, it might be K. That seems to ring a bell here. Yep, capital K, that's it. So make FS, XFS, capital K, dev mapper, test VDO2. Got our file system. So if I were to VI etcfs tab, and we want to do this. So what we have to deal with is you cannot use UUID. I did a little test run of this, and what I did for that was try to map with UUID, and basically it made the system did eventually boot, but it seemed like it took forever because of the system not being able to mount my ext4 volume. So what we're going to do is add a line. So I'm going to do dev mapper test video2 mount XFS, which I need to create that. It'll be XFS for the file system defaults. For VDO, we need to add a couple of things. Now, one of the books I did use for my training only had us putting the requirement for the video service. Red Hat documentation has a couple of extra things, and one of which is underscore netdev. The other is xsystemd dot device dash timeout equals 0, and then xsystemd requires, which is what you would expect this to have, requires, yep, video.service. Because this service needs to be running, otherwise it's not going to be able to mount the file system. Or, yeah, it's not going to be able to mount that file system to where we want. Then we'll do 00 for our for the backup dump and FSCK check. So close that. Let me go ahead and make our mount. Dear MNT XFS. One other thing I'm going to do real quick. This is outside the scope, but I want to see how this is going to work. Is this the file I want? No, that's not the file I want. What I want to do is turn off the, or I could probably just do that in the grub menu. Alright, so we're going to reboot and see if this does what I want. Alright, and here we are. I'm going to edit our little grub entry here. I'm going to remove those two things because I want to see all of the messages that are going to be coming up. It's probably going to go too fast for me to even read, but if it errors on making the mounting our XFS file system, I want to see where it errors. So all this has seemed normal so far. Yep, and there we are. So when I did this by UUID, it took forever to boot. So let's make sure that our file system is still there. Little VM's taking its sweet time. I should beef it up and give it some more RAM. Who knows? All right, DFH. And there we go. There's our dev mapper. So if you do UUID, this is probably not going to work. I can't tell you why that is, but we do have the XFS file system. And as far as that ext4 file system that I broke, I might do a follow-up video someday of troubleshooting that and actually getting it. But I think the lesson to take away for the RHCSA exam is don't stray from the objectives, because I was just trying to prove a point about the physical storage for VDO, and B, be very careful not to run out of storage because that'll cause some problems for you. So hopefully you enjoyed it, maybe got a little laugh out of my file system issue. If you did, make sure you click like on the video. Also, make sure you subscribe to the channel, ring the bell when you do. Thank you for taking the time to watch, and I'll see you the next time.